before my fingers heat this up. So room temperature, is that cold? Kind of feel cold to the touch? What do you think? Does it feel cold to the touch?
Yeah,
A little cold to the touch. All right, now my fingers in itself, so you guys are going to need to come over here a little bit so you can see. So move in, so because I'm going to be working right in front of the table here. So kind of scooch in so you can see. Now, of course, I can heat this up just by keeping my hand over there. My body heat. What's the average temperature of the human body? 97, 98 degrees, right? So is that Fahrenheit or Celsius? That's Fahrenheit, right? So my body temperature can heat this up. Now, right now the room temperature in this room is about probably around 68, 70, somewhere between 68 and 70 degrees. In a material testing lab, you would have to maintain that temperature in the room because we want to kind of control thermal growth. So, because materials expand and contract with temperature. So, and we'll learn more about that in the materials testing class. But this is a piece of stainless steel. This is stainless steel welding rod. I'm going to kind of show you the malleability of this particular material. Now, as you take a look, so I've got some other materials. I've got a nice piece of solid red oak. This is a remnant cut off of my, we made some countertops for our kitchen. This is a remnant from that when I did that. Now, you can kind of see, how many of you say that hardwood like oak is very hard? Is wood, oak especially very hard? Yes, it is. I dented it, right? So just because a material is hard doesn't mean that it is impervious to scratches or dents. Or very tough. I should say the oak is very tough, strong material, but it's not a very hard material. So it basically, that hardness in there still allows us to dent and scratch that, all right? Now, I have my anvil here. So this is the best anvil that you can buy over at I can't think of that name of that tool store. So we get all sorts of cheap tools at over there. Harbor Freight. So this is the best anvil that we can buy over at Harbor Freight. Now, this is not like my $1,000 300-pound anvil that I have at home. So this is basically about a $50 anvil. It is a cast iron. So it's cast iron as well. And of course, if I were to hit this like this, you can see where students have already done it. You can kind of see the dents in there. So it's a very strong material. Cast iron is very strong, but it doesn't have a lot of hardness to it because we make dents and indentations into that. Now, I'm going to take this stainless steel. So you guys all felt the temperature of it, right? So I'm going to use the malleable nature of stainless steel, and I'm going to flatten this from the round rod. So this is about 1/8 inch diameter round rod. So I'm going to flatten this. All right, this is my volunteer. Come on up, come on up, Torrance. All right. Touch it. Don't grab it, just kind of touch it. Oh, it's very hot, right? So hot enough that it wouldn't really burn you, but it's definitely hot. So why is that so hot right now?
The friction from you.
Not so much friction. So I was breaking the grain structure of on the molecular level. In order for me to change that from a round diameter into a flat stock, I got to break that grain structure. And there's a little miniature chemical reaction that's occurring in there, and we're getting that chemical reaction released in the way of heat. Yeah. So that's what we're going. Now, heat does a couple of things to steel. So I'm at the other end right now. So we're going to take this. So you guys know, so notice if I took this and kept moving it back and forth, so what would happen? So eventually, what would happen if I just kept moving this back and forth? It would eventually break. So, right? So right now, it's pretty resistant to that. So it doesn't break that much. So let me kind of come back over to here for a second. Let's flatten some more. Now, with that change, so at this point, I kind of made this material a little harder. So, and in so doing, usually sometimes that will make it easier. The harder a material is, or the harder a material becomes, the more gets. So from my forging it, the more brittle it becomes. So as we would do this, that brittle nature makes it easier to kind of bend, and it would eventually break there as well. So just a couple of examples of some of the physical properties that we would use in order to get and shape the material to the way we need it. So go ahead and put your safety glasses away, put them back in the box.